So the project we did was on clock cycles and the codes on the bars. It was section 2.4 in the book.
The agenda for today is the overview, time, clock arithmetic, days of the week, equivalence, practice makes perfect, the hot questions, the cool answers, the mod world of modular arithmetic, check digits, checking checks, in Mindscapes.
So for an overview, we have cycles, and basically they occur multiple times in a day. For example, the seasons, the times on the clock, and birth and death, and they can be used as models for mathematical insights. So a quote seen in the book is, "Sure, numbers are involved. The time of day is expressed in numbers, as is the price of an item, but these numbers are neither deep nor powerful anything. This is how the average person feels on a day-to-day, and exotic numbers exist in every day. Little do they know."
Time. The first section in the book was talking about time, and it was talking about the essence of time. A clock cycles around in the same directions every day, every minute, every hour, and every second. The highest number on the clock is 12, and then it restarts to 1. An example is, if you start at 9 and you add 37 hours, what time will it be? It'll be 10 p.m. Clock arithmetic. This section is considered to be clock arithmetic. The time 12 can be compared to 0. So whenever you start back at 12, you're actually trying to start back at 0. An example, going back to the last section, was 9 plus 37, so it would really be 12 plus 12 plus 12 plus 1. We have to remember that adding 12 is like adding 0. Therefore, 9 plus 37 plus 1 equals 10. Clock arithmetic, days of the week. Think about if a clock had numbers between 1 and 7. This clock is comparing the days of the week on a clock. So that means 6 plus 4 equals 10 and is equivalent at 7 plus 3 equaling 10. Equivalence. Looking at a cycle develops the idea of equivalence. An example is 37 is equivalent to 1. Say there's a clock that has 9 hours on it, and the hand on it is at 5. According to this clock, adding 9 doesn't change what the clock reads, so we'll be back at 9 again. So we can say that 9 is equivalent to 0. This is called a mod 9 clock arithmetic.
So practice makes perfect. Some answers will be equivalent, but some won't. If numbers don't match, go back and check your arithmetic. Every case has a different mod number, and you must look at mod n.
The hot questions. Example, is 26 plus 31 to the 5th equal to 0 mod 29? Proof. 26 plus 31 to the 5th is equal to 26 plus 29 plus 2 to the 5th, which is equal to 26 plus 2 to the 5th, which equals 26 plus 32, equals 26 plus 29 plus 3, equals 26 plus 3, equals 0 mod 29. In this case, the statement would be true since we're looking at a mod 29 clock. 29 is equivalent to 0. We had to figure out that 31 to the 5th was equal to 28, 629, and 151. The cool answers. Take a moment to look at letters A, B, and C. For A, is 7 raised to the second plus 5 times 57 equal to 40 mod 48? A would be incorrect because 7 to the second plus 5 times 57 equals 49 plus 5 times 9 equals 1 plus 45 equals 46, not 48, and also not 40. B, is 2 to the 4th plus 5th to the 301st plus 6 times 31 equal to 3 mod 5? B would also be incorrect. 2 to the 4th plus 5 to the 302nd plus 6 times 31 equals 16 plus 0 to the 301st plus 1 times 1 equals 1 plus 1 equals 2 mod 5, not 3 mod 5. C, is 9 raised to the 2000 equal to 1 mod 80? It helps to write 2000 as 2 times 1000. C would be correct. 9 to the 2 times 1000 equals 9 squared times to the 1000 equals 81 to the 1000, which equals 1 to the 1000 equals 1 mod 80, like it had said above.
the mod world of modular arithmetic. The clairvoyant Kleenex consultant. You read a 12-digit barcode on the bottom corner of a Kleenex box. These barcode lines are also known as universal codes. You read numbers 03600281509. You are immediately corrected that you had read it wrong and asked to read it again. So the second time you read 03600285109. You notice that you switched the 5 and the 1. The customer service knew you were wrong by using modular arithmetic.
Check digits. A barcode is usually made up of 12 or 13 digits, which make up a universal product code, also known as a UPC. It contains 3 components. The first 6 digits are the manufacturer information, the next 5 digits are product information, and the remaining number is the check digit, which is a way to identify if the UPC number that had been input is correct or not. Any method can be used to compute the first 11 numbers of a barcode as long as the check digit at the very end added to all the rest is equal to 0 mod 10. 10 is equal to 0 in mod 10. If we have a barcode and all the first 11 digits add up to 1, then the check digit has to be 9 because 9 plus 1 equals 10, which is 0 mod 10. If we have a 12-digit number and the check digit is 7 and it doesn't all add up to 0 mod 10, then we know that there has been an error. Checking checks. On every U.S. check, in the bottom left-hand corner, there is a collection of 9 digits, with the last one being the check digit. Using an error checking system, you can find any one error or switches between 2 digits when one is read incorrectly in a code. Example. We will call it 9 digits of a check N1, N2, N3, N4, N5, N6, N7, N8, and N9. We will then use this error checking system listed below. After computing the given numbers into the system, it will have to equal 0 mod 10. If it does not, then we will know that an error has occurred in the system. Let's say that the 9 numbers are 1, 2, 0, 0, 1, 0, 1, 4, 3, and plug them into the system above. It would list as it does below, and it equals 62. Since 62 does not equal 0 mod 10, which is also equivalent to 0, we can conclude that there has been an error somewhere in the system.
The mindscape we chose can be found on page 92. The mindscape that we chose was number 1, a flashy timepiece. You own a very expensive watch that is currently flashing 3. What time will it read at 12 hours, 14 hours, 25 hours, 240 hours, and what time is it when an elephant sits on it? The trick to finding what time it will read in the future is easy, as long as you use modular arithmetic. Your new fancy watch is just another cycle of life because of the numbers it reads on its surface. There are 24 hours total in a day, but only half of that cycle is shown on a clock. Therefore, the cycle has to occur twice in one day. If you want to find a future time, you have to apply the arithmetic. For example, if you want to find out what time the clock will read 12 hours from 3, it will still read 3. This is because 12 is really equal to 0. Next, if your clock reads 3 in 14 hours, it will read 5, because 14 is really equal to 2. Next, if your clock reads 3 in 25 hours, it will read 4, because 25 is equal to 1. Next, if your clock reads 3 in 240 hours, it will read 3, because 240 is equal to 0. Finally, if your clock reads 3 when an elephant sits on it, it will still read 3 after, because it will immediately break in the same position.
Here is Mindscape number 9, Celestial Seasonings. Which of the following is the correct UPC for the Celestial Seasonings ginseng plus herb tea? Show why the other numbers are not valid UPCs. For these 3 UPC numbers, if we multiply every other number by 3, including the check digit at the end, which is 8 for all 3 numbers, let's see which one could be the possible UPC for Celestial Tea. After multiplying every other number by 3, for number 1, we would come out with 43. And this cannot be the correct UPC because it is not evenly divisible by 10. Number 2, if we multiply every other number by 3, including the check digit, we would come out to 40. And this could be the possible correct UPC because it is evenly divisible by 10. And for number 3, if we multiply every other digit by 3, including the check digit, we would come out with the number 42, and this cannot be the correct UPC because it is not evenly divisible by 10. To conclude, the second code is the correct UPC code for the Celestial Seasonings herb tea.